All right, let's try to tackle this homework 7, shall we? All right, let's take a look at problem 1. Key pieces of information they give us. Sample size n is 100. Produce a sample mean x bar is 16, assuming the population standard deviation sigma is 3. So this is quantitative data. We're also given n is 100. That is at least 30, which implies it's large, which implies we're going to use the z distribution. So we're going to use z, we're 95% confident, we're going to use z interval. All right. Now, in my online posted solutions, you've got all of the different things, but I mean, really, we're just going to go into the calculator and run the z interval. Turn it on, I guess. Stat calc. Tests. Z interval is number 7. We're giving it statistics. Sigma is given as 3. X bar is given as 16. N is given as 100. Note you should not have S of X there. That would be a T. 95% 0.95 is good, so let's go to calculate. And so I've got the interval, 95% confidence interval is simply 15.412 all the way to 16.588. That's an 8, excuse me. Clean that up, sorry. Okay. All right, part B, so we're still using problem 1. Assuming the population standard deviation sigma is 3, how large should the sample be to estimate the population mean mu with a margin of error not exceeding 0.5? All right, so let's write down our standard formula for this. Again, we're all the same stuff from A, so it's a z distribution, and it's quantitative. So n has to equal z of alpha over 2 times sigma all over the margin of error E, all that squared. Okay, so let's put that in there. 1.96 is what we're going to get for z of alpha over 2. How that comes out, alpha is 0.05, which means that alpha over 2 is 0.025. We use the inverse norm of 0.025. This is also one of the commonly used ones that are talked about in the videos as well as on the PowerPoint, but we'll do it anyway. Second vars, inverse norm, 0.025 will give us 1.96. If we use the negative value, that's no problem. We're squaring it. We'll become positive anyway. No problem. Sigma is 3. The margin of error is given as 0.5. All of that is squared. And this comes out to 11.76, which we square, which is 138.3. Now the rules with this is n, we want an n, the smallest n possible. All right, so n has to be larger than this, because if it's 138, obviously we can't have 138.3 people, can't have a part of a person, that's not going to work. Part of a data set, whatever. 138 is not big enough, so this means we're going to use 139. We round up with these problems. That was talked about in the other videos as well as in your notes on PowerPoint. Okay. Number 2, Bernoulli trials is a binomial, which means we're doing a probability of a success. So we get 28 successes in 70 different trials. That's going to give us n is 70, and x is the number of successes, so that's 28. If we want to calculate p hat, that's simply x over n, or 28 over 70, and our calculator will do that for us. as just 0.4, it looks like, if that's necessary. But what it wants is a 90% confidence interval. That means we're going to use one prop z int. Okay, so we'll go do one prop z int, see what it says. Again, there's only one for proportion. We're going to assume that our NP is large enough. It looks right. We got 0.4 times 70 is 28, and 0.6 times 70 is going to be a larger number. We just need it to be 10, so that's no problem. Excuse me, 15 for here. At any rate, one prop z int, stat tests. That's one prop z test. That's a test for hypothesis. We're not doing that yet. All of these are well named, so be careful. One prop z int is a. X is 28. N is 70. And the confidence level is 0.9. And we simply calculate. So typically we want to give it 3 decimal places, but let's see, 0.30, that would be 4. And then we got 0.496. You can give it more, that's certainly fine. All right, number 3. Operators manager, large population, would like to estimate the mean. Again, we're talking about a mean here as a key word. Means we're going to deal with either the z or the t, depending upon our n value. The mean amount of time worker takes to assemble a new electronic components, assume that the standard deviation is 3.6 minutes. This is sigma. After observing 120 workers assemble similar devices, managers noticed the average was 16.2. That means n is 120, x bar is 16.2. We want a 92% confidence interval. This number at 120 is at least 30, so we'll use the z interval. Same as we did in the other problem. So again, stat tests, z interval is number 7. So the first stat is sigma is 3.6, given up there. I've got it listed, 3.6 there. X bar is given as 16.2, and n is 120. This instead of 0.9, we're going to use 0.92. And we go down to calculate, and this is it. So this is 15.625 all the way to 16.775. That's the interval, and we're good to go. So now we're looking for how many workers should be involved in the study in order to have the mean assembly time estimated up to plus or minus 15 seconds. Well, let's take a look at what we did here. Average time is in minutes. Standard deviation in minutes. So 15 seconds is how many minutes? Well, it's 0.25 minutes. .25 minutes. So our n in this situation, little n, sorry, is simply our z of alpha over 2 times sigma over our margin of error e, all squared. Well, our z of alpha over 2, if alpha is 0.08, because we have 92%, that 1 minus 0.92 is 0.08. That gives us alpha over 2 is 0.04, and the inverse norm, 0.04, or would be 0.96. I guess we could just say the negative inverse norm of 0.04. Second bars, inverse norm, 0.04, gives us negative 1.75. Negative of that is 1.75. So this is 1.75. Sigma is again 3.6. And E we calculated to be 0.25, all squared. Comes out to be 635.04. We have to round up. That's the rule. So 636, and minutes is our units. So we're good with that. And number 4 is another sample size. See what pertinent information we have here. Find the proportion. So we're going to use the proportion formula. Of customers who bought the newest MP3 player. How large a sample size do we take with a margin of error? 2%. And then 90% confidence. Okay. What don't we have here? We don't have an estimate for P. So no estimate for P or P hat, essentially. No estimate for P or P hat. So for P, so P hat will equal 0.5, and 1 minus P hat will equal 0.5. 0.5 times 0.5 is 0.25. That's what we'll use, and that's one of the formulas we have. So in this case, N equals same Z of alpha over 2. That's squared. There's our 0.25 right there, because we don't have P or Q. And this bit here, this is Q hat. And then error squared. So we're looking at 90%. Well, the inverse norm of that is 1.645. Excuse me, this should be 0.25, not 2.5. I've done it twice. Let's correct that. And E is 2%, which means 0.02. Change it to a decimal. And that'll be squared. So when we do this in the calculator, it's 1691.27, which again we have to round up. I know 2.27 goes down, but the rule for this is we want the smallest n possible that's going to work. It won't work for the regular rounding. We always round up. So 1692 is our answer. And that's how we do this homework problem and all of this homework 7.